Alright everybody, welcome back. This is part 2 of our CNC machining tutorial set. Let's see, in part 1, as just a brief overview, we talked about geometry creation, pattern creation, and how we export geometry and specifically the file format. And as a reminder, we're looking for a .igs file format out of Rhino. Our CAM software, PowerMill, this is the file type that it likes best. It's a selected surface model type that's essentially universal. Let's see. So in order to do this, there are 3 things we need to talk about first. One, you will definitely need your geometry, your IGES geometry that you created. That's step number 1. Step number 2, on Canvas, there is the Project 6 CNC Machining Setup and Template File Compressed folder. You're going to need to download this and then bring it onto your computer. If we double click on this, since it's a compressed folder inside Project 6, okay, we're going to take this and just bring it onto the desktop. Okay, and we can get rid of that. And inside of here, okay, is some files and a session and a tutorial for you to use. This PowerMill template 4 is a PowerMill session that we're going to open in PowerMill that has everything that you need in order to do the programming. It'll be nice and simple. This PowerMill programming tutorial version 1, this PDF, if you don't want to listen to my melodious voice, this is essentially a step-by-step process that takes you through the programming. Step 1, step 2, step 3, step 4. This may be a little bit easier to follow than trying to watch a video. And then this folder right here, section number, student name, file folder, that's where everything is going to get saved. And you are actually going to rename this for yourself. Whatever section you're in, your name, file folder. Okay. This is where you'll want to put your IGES geometry, and this is where you're going to put your PowerMill session once you save it. Just as a good place to keep everything organized. Okay, so we will minimize that. All right, and for number 3, PowerMill is an Autodesk product, but it is not available to students. You actually have to buy this license, and it is not the cheapest thing in the world. It's one of the better CAM softwares for CNC machining, and therefore it is buku expensive. It is not available as a free license, free software for students, unfortunately. But it is downstairs in the Computer Graphics Center lab, the CGC Computer Lab. All the computers have it. So you will have to do this programming from one of those computers. You'll simply just log in as yourself using your UCID and password, and you'll get your Project 6 template files. You'll bring your IGES files, and then we'll do the process from there. So let's begin. You've logged into your computer. First step is we're going to go down here to the search bar, and we're going to look for PowerMill. Spelling is important. PowerMill Ultimate 2021. That is the version that we will be using. If you saw like the PowerMill 2017, that doesn't work. You will need to use specifically the 2021 version of this. Okay, so welcome to PowerMill. Let's see, some basics for beginners. Navigation. If you middle click the mouse button on your the scroll wheel, that is orbit. If you hold shift and middle mouse scroll wheel button, that is pan. Okay. Up here on the right hand side, these are just different views. If I hover over, I can do a top view, bottom, right, left, front, back. Right. This is called our shaded view. This is called the wireframe, and this is the block. We shouldn't really need to worry about these, but I'll show you once we actually get some geometry in. Let's see. What we're going to do first, we're going to open PowerMill first, which is what we've done, and now we're going to open the template file. So I'm going to come up here to open, and I'm going to navigate to the desktop, Project 6, CNC Machining Setup and Template Files, PowerMill Template version 4. We're going to say OK. Okay, now we have geometry in this session, and geometry and kind of everything set up specifically for this project, for this process. The CNC machining that we're doing is a fairly prescribed method. It's very, very narrow in its focus. This is not meant to be even really a primer on the, I guess you would call it, the complexities of CNC machining. This is simply a method of exploring the programming method and the process that is programming and geometry creation. Okay, so what we see here on the screen, all right, this represents our material. This shaded block represents our material. This represents a tool that we'll be using to actually do the carving of that material, and this is part of our setup that is going to be on the Bridgeport CNC mill upstairs in the RPC. Okay. Let's see, on the left hand side, these 7 things here: rough, semi-rough, finish, perimeter cut, pattern 1/2 inch ball, pattern 1/4 inch ball, pattern 1/8 inch ball. These are called toolpaths, and essentially they are methods of movement. Methods that we tell the machine to move in very, very specific ways. Okay, and this folder right here, we see this little plus sign. We click that. This is something specifically for when we do what's called the Viewmill simulation. That's a digital simulation of how the cut is progressing, and we'll get into that here in a little while. All right, so now that we have the template session open, the first thing we're going to do is we're going to right-click on anywhere on this in this white area. Right-click, Set DAP PowerMill Session, and it's going to think for a second or two, or more, doing its thing. All right. So that red, essentially, what the Set DAP PowerMill Session does is sets some of the macros, the background macros in place to allow for this type of programming to happen. Okay, so when you open this and you see this red, the first thing you want to do is set the DAP PowerMill Session environment. Okay, now that we have that, step number 2 is we're going to import our IGES geometry into this session. Okay, and the method of us doing that is we're going to come over here to the left on models. If we expand this, we currently have 3 models in place. We have the Bridgeport palette, which is this top one. We have the this is kind of old, but Project 5, Project 6, PowerMill setup template. Earlier I talked about how the wireframe, if we click on this, this just shows a little bit extra, specifically 2D information. When this is off, all we see are surface geometry, and with this on, we see the surface geometry and the wireframe. Okay, but we need a third model, and that's actually our programming geometry. So I'm going to right click on models. We're going to say import model. We're going to navigate to where our IGES geometry is located. And we saved it in our project 6. And we're going to say open. Okay, so now we have our surface geometry, our pattern geometry, our block geometry. Okay, this is our origin. And now we're almost ready to start. If we come back over here to the left again, we come over to levels, sets, and clamps, and we expand that. These are essentially layers. One of the things I dislike about the IGES file format is that when you import information into PowerMill, the layers don't come in, but the layer names don't come in, but the layers themselves do. So this layer 6 is our pattern geometry, and just to keep things organized, I'm going to essentially just rename these real quick. All right, and to help us, that may be material. All right, let's call this surface geometry. Okay. Okay. These other two we're not going to worry about. All right. And this information dialog, we can just close that. All right. Now, the next thing we want to do, and the thing we want to do often, is we want to save the session. All right, so we're going to say File. We're going to say Save As, Save Project as a PowerMill project. And I'm going to call this section number, my name, and I'm going to call this PMill. And version 1, just be safe. Okay, so if we go back, all right, there's our template and our folder. We see this PowerMill session right here. Technically speaking, this PowerMill session is a folder as well. Okay, but what we need is we need all of this information. This is all metadata necessary for the programming to happen. Okay, so we need all of this information, not just a little bit of this information. But we'll go over saving all this whenever we're done. Okay. All right. So now we're ready to start. If we right-click on rough, when you say activate, one more time, activate, you'll see how the name is blue, and there is this like an alligator mouth. That means this toolpath is active. Now that it's active, if we right click again and we go to settings, and it may take a second or two, there we go. This is what's called a toolpath strategy. This is a model area clearance toolpath strategy. This toolpath is specifically designed to remove material, essentially material between the block that represents the material that we're going to be cutting and the geometry inside of that block. Essentially, anything that's above the surface, outside the surface, inside the block is going to get machined away. And that's exactly what we want it to do. And I'm going to turn off wireframe just to make it a little bit more apparent. Okay. Now, the cool thing about this particular setup that I've created for everybody is beyond activating the toolpath, right-clicking, getting into the settings, seeing this, the only thing you have to do is click calculate. That's it. That's the only thing. This toolpath is now programmed. And it's programmed enough to do exactly what we need it to do. All right. Now, what we're seeing is essentially toolpath lines. These green lines that we see, this represents the center of the tool as it moves through the material. These orange moves are called linking moves. So at the end of one toolpath, how it can move to the beginning of the next toolpath. So we see end, link to the next, toolpath, link to the next, toolpath, link to the next, then toolpath. All right. These cyan and these dashed red moves are how the tool is moving from one spot to another spot. Okay. This represents how the tool is going to move in this particular strategy. This strategy, like we said, is specifically geared towards just removing material to get closer to the geometry. Now, what exactly does that look like? Well, we can test that. So I'm going to say close for right now. But we also want to save. You can't save too much, but you can definitely save too little. PowerMill has an unfortunate thing of crashing when you least want it to, and there is no autosave function, and there's no Control Z function, which is always lots of fun. But what is this cut going to look like? That is an excellent question. We're going to visually simulate this. To do that, we're going to right-click on Activate Me to set up Viewmill simulation. Right-click, Activate. All right. Currently, we're in the Home tab, and 99% of what we're doing is going to be in the Home tab. But now we're going to move over to the right to what's called Simulation. Okay. We're going to click on Simulation. Next, we're going to click on Off. This turns on the Viewmill simulation. Next, we're going to go to Mode, and we're going to go to Fixed Direction. All right, this makes it just a little bit prettier. Shading, we're going to come down to Rainbow, because we like color. Next, we're going to come to Entity. All right, click on this. We're going to select Rough. All right, this is the tool that we're going to use that's been calculated with this particular toolpath, and we're going to say play. And so this is the tool moving through the material, removing material that's above the surface geometry. And this is what the material block will look like after this toolpath is done. Now, the question we want to ask is, does it look like the surface geometry that we created? No, but we start to see some of its major features. You know, this high point over here, this high point over here, this valley, this low point, these medium points. Okay. Now that we have done this toolpath, now we move on to the next one. So what we're going to do is we're going to come up to Mode, click on Mode, we're going to say No Image. Okay, that takes us back into here. And we're going to come back to the Home tab. Okay, now we are ready to program our next toolpath. Okay, so we're going to right-click on Semi-Finish, Activate, right-click, Settings. Takes a second. There we go. And again, the only thing that we need to do is say calculate. All right. And now we have our new toolpath lines. And just because we can, we're going to go ahead and do the next two, the finish and the perimeter cut. So right click, activate, right click, settings, calculate. Okay. And then we can close that, and then right click, activate, right click, settings, calculate. Okay. So what do these three toolpaths do? Right click, activate. The semi-finish is about material removal. It's getting the stairs. It's refinement. It's helping to get rid of the stair steppings that we saw in the rough. And if I turn on this light bulb, you see that. Okay, I'm going to turn that back off. But it's primarily about material removal. It's the tool itself isn't touching the geometry, and the toolpath lines we see are fairly wide apart. Okay, but if we right click on finish, activate, right click, settings, we actually don't really need this. We just close that. This is about final surface refinement of the three-dimensional surface. This tool is actually touching the surface, and we see that these toolpath lines are much closer together than in the semi-finish. Okay, essentially this toolpath is specifically replicating the curvature of the surface itself. Okay, and then right-click, activate on the perimeter cut. This is simply just cutting the outside to make it nice and accurate. Okay. Now that we have these toolpaths done, these four toolpaths done, we're going to click and save. Okay, now, what does our simulation look like now? Well, let's go back. So, over here to the right, simulation, click on that tab. The simulation is still on, so we're going to go to the mode and we're going to say fixed direction. Okay. So now, over here on left to entity, we're going to go from rough to semi-finish, and we'll say play. Now we're not seeing the tool, and that's fine. If you wanted to, we'll just pause that. If we right-click on semi-finish and we say activate, now that tool shows up. Okay, and then play. Technically speaking, though, the simulation is a little bit quicker to do with the tool off, but it's cooler, I think, when the tool is on. All right, so semi-finish to finish, and if we want to see the tool, right-click, activate, and we'll say play. Okay, so one of the things we'll notice is this is taking a lot longer because the toolpath lines are a lot closer together. There's a lot more of it. So these features right here that we see, these are called the cusps. This is essentially a ridge that the ball mill, which is what this tool is, leaves behind. In the semi-finish, since we're mostly worrying about material removal, that looks pretty coarse. And in the finish, that cusp height that we're seeing is much, much smaller, which makes the surface read that much better. But the caveat being that it takes a little bit longer to machine. Okay, so the surface is nice and clean. We've got this little stuff around here, but that is going to go away when we do the perimeter cut. Okay, so at this point, we have recreated the 3D surface that we modeled in Rhino. We're like half the way there. But now the real fun really starts to begin. All right, so we're going to get out of the simulation. So mode, we're going to say no image. And we're going to right click on perimeter cut and deactivate. Okay, I'm going to zoom out a little bit. So without the wireframe on, things are pretty nice visually. But turn this back on, we now see a lot of our 2D information. All right, specifically looking for the pattern, which is right here. If we come over here to the left-hand side, we'll see this called patterns, and we're going to expand that. We'll see a pattern A, a pattern B, and a pattern C. Depending upon how many patterns you have and how many you want to bring into PowerMill, this is just a way to keep them organized. So what I'm going to do is I'm going to right-click on pattern. I'm going to say select all. And because it's on its own essentially layer, only things on that layer select. All right, and we know it's selected because the geometry itself is yellow. So just like in Rhino, anything you select by default turns yellow. Okay, so with this selected, I'm going to come over to pattern A. I'm going to right click on pattern A, and we're going to say insert model. All right, so now this looks kind of bold. If we click anywhere out here, deselects, and I'm going to turn off the wireframe. Essentially what we've done is we've taken this 2D information and created it into 2D, into PowerMill's version of 2D geometry. Now this 2D geometry we can now use to drive a toolpath calculation. So now what we're going to do is I'm going to come over here to pattern half-inch ball. Now I have a vague idea of what this is going to look like. What I don't know specifically is how the different diameter end mills that we're using, either a half-inch, a quarter-inch, or an eighth-inch, is going to look once we do the programming and once we do the Viewmill simulation. So what we're going to do is this. We're going to right-click on pattern half-inch ball. We're going to say activate. We're going to right-click again. We're going to go to settings. All right. This is called a pattern finishing toolpath strategy. And what we're going to do, this is slightly more involved than the other types of programming. And so instead of it being one step, it's now two steps. The first step is going to be, we come down here to pattern, toolpath entity. We're going to pick on pattern A. And then step number 2 is we're going to say calculate. So from 1 to 2. Okay, and then close. Now, what we don't see, or we see some things and we don't see some things. So unlike these other toolpaths that were above the surface, we don't see any of the green lines. We see lots of movement lines, but none of the green lines. If we turn off the plane shade, there they are. Okay, and so essentially these toolpath lines are now underneath, inside, below, deviating into the surface geometry that we've created. All right, which means that it's cutting into it. So now the question is, okay, well, what does this look like? Well, we're going to come up to back up to mode, and we're going to say fixed direction. And what we're going to do is we're going to come up here first. We're going to say store. Saves the current state of the Viewmill model. We're going to click on that. Okay. And then over here to the left to entity, pattern half-inch ball, and all right, keep a mental image of what this looks like. Play. Oh, that's loud. Possible rapid moves into stock has been detected. Simulation has been stopped. We don't care. Okay, we're going to say play again. wait. Okay, so we see that it's taking a while. If we simply say pause, and we don't want to wait around on this, we're going to come over here to the left, Bridgeport. Whatever is bold is what's currently being used. So if we come over here and just turn off the light bulb, oops, the tool goes away. If we hit play, it makes it much faster. And it can take a minute. Almost done. Alright. When this progress bar gets all the way over to here, then we will be officially done. Alright. And now we're done. Interesting. Visually interesting. I don't know if this is really what I want though. Okay, so what I'm going to do is I'm going to come back to restore. That takes us back to the previous step. In order for restore to work, you have to store it first, unfortunately. All right, so mode, back to no image. So what I'm going to do is this. I'm going to right click on pattern, zoom out a little bit. Oops. Zoom out a little bit. Orbit round, right click, activate, right click, settings. So instead of the 1/2 inch ball, let's try it with a 1/4 inch. Okay, pattern A, step 1, and then step 2, calculate. Okay. And because we haven't done it for several steps, I'm going to come up and say save. I can tell you from personal experience, nothing hurts quite as much as your PowerMill session crashing and realizing you've lost half hour, an hour, 5 hours, 10 hours worth of work. It's a it's an interesting pain. So we're going to come back to mode, from no image to fixed. Okay, instead of the pattern 1/2 inch ball, we're going to say the pattern 1/4 inch ball. Let's go ahead and start that. Now this is different. This is, I think, potentially much more interesting because we're using a smaller diameter tool instead of completely destroying, or not destroying, but getting rid of this top surface that we've created. We're leaving just a little bit of pieces left. Possible rapid move into the stock. We don't care. Play on. Now, this is similar to the 1/2 inch, but we're seeing some of the surface beforehand. Not a lot. Now, if we go smaller, what I predict will be different is we'll see much more of that surface. And I'm interested to see what that looks like. So we're going to say restore, mode, no image, and we're going to come back to our toolpaths, We go to the pattern 1/8" ball, right click, activate, right click, settings. Alright, step 1, pattern, and step 2, calculate. Okay, and so now we go back, fix direction from 1/4" ball to 1/8". You see this is much smaller now. Play. Ah, very interesting. Man, it's really loud. Possible rapid move into the stock have been detected. We don't care. Play on. Okay, see if we can make this go a little bit faster. I'm going to turn off the tool, click play one more time. There we go. The simulation itself is fairly graphics card heavy. So the more things it has to do in real time, the longer things take. All right. Now, in my opinion, this is the most interesting because we're seeing portions of the original surface and the pattern being created. In my opinion, this is fantastic. Now, there is a way to view this without the colors. If we come up to shading and we simply say plane, this is just a plain gray view. If you wanted an idea of what this would look like if it was out of metal, shading, come down to shiny. Ooh, pretty. Okay. The rainbow view is helpful simply because it helps us see what toolpath did what. All right. Now the question is, are we happy with this? Do we want to try anything different? Well, if we did, what we would do is we would come back into PowerMill and we would say, this was fun, but maybe this one is the right way to do it. All right, so what we're going to do is we're going to right click on our pattern, select objects. Let's move this our designated distance. Okay, and now what we're going to do is we're going to select all this, file, export selected as an IGES, project 6, and we'll call this version 2. And OK. File successfully saved. All right, so I'm going to minimize that. Come back into mode. Come back to home. Okay, and now what we're going to do is I'm going to come down here to, since I'm going to import new geometry or more additional geometry. So I'm going to call this, in the levels and sets, I'm going to call this pattern A. Okay, and I'm going to deactivate, right click that toolpath, and I'm going to turn off pattern A. Okay, and I'm going to turn off the 2D geometry that we imported for pattern A. And now I'm going to come up to, or go to models. I'm going to right click. Oops. Oh, is my thing's getting in the way. Sorry. There we go. Import model. We'll call this version 2. Okay. Technically, there's copies on copies, but right now that's actually not a problem. So what we're going to do is, there we go, is we need to find our pattern again. So I'm going to turn that off. Nope. Nope. There we go. I'm going to call this pattern B. Okay. Now, I'm going to right click, select all, click on pattern B, insert, model. And now what I'm going to do is I'm going to recalculate some toolpaths. Okay. What I'm going to do is this. I'm going to come back over to simulation. Well, actually, no, I'm not. We're going to right click on pattern half-inch ball, activate, right click again, settings. Okay. If we notice all this is grayed out and we can click on stuff, but we can't make any editings, any changes. What we have to do is you have to come up here to this recycling symbol that reopens the toolpath. So instead of pattern A, I'm going to come down and I'm going to pick pattern B. And I'm going to say calculate. Okay. Now visually, one of the things we notice is that there's a lot less motion moves than there was with pattern A. Okay, so now we can close that. I'm going to come up to simulation and mode, fixed direction. Okay, we're going to say restore, take us back. And we're going to say, we're going to run the half-inch ball. And then play. Possible rapid move, we don't care. Play on. Okay, so because this pattern is much less dense, we're seeing a lot more of that surface area. Okay, so this is now the game that we now have to play. You know, playing around with the pattern in Rhino, bringing that pattern into PowerMill, playing around with the programming. Which tool do you use? Do you use the half-inch? Do you use a quarter-inch? Do you use the eighth-inch? You know, it's a constant. I mean, it can be a constant back and forth. Using the Viewmill simulation to really get an idea of what the end product is going to look like. Okay. So now we have a decision to make. Are we done? For the sake of trying to keep this somewhat short, we're going to say yes. We're going to say that this is perfect. This is exactly what we want. This half-inch ball is the toolpath that we want to use to move forward with. That's perfectly fine. So, back to no image. Okay, so what we're going to do now is we've said this patterned half-inch ball is exactly what we want. Okay, the quarter-inch, the eighth-inch, not so much. So what we're going to do is we're going to take the quarter-inch ball toolpath, we're going to click and drag and put it into do not use. If we see the little plus sign, that means it's moved. And if we expand that, this pattern quarter-inch ball is now in that folder. Okay, and then we'll do the same thing. All right. By doing this, you are telling us, myself, Lauren, the GAs, that the half-inch pattern, or this particular pattern is what you want, and specifically the diameter of the tool is what you want. Okay. So now we're going to say save. Okay. And now we are done. Save. We can we're going to minimize this for just a second. Okay. So we said before that this is a folder. If we double click on this, we see all these things inside this folder. Okay. One of those things is this log file. Okay. This makes it so that anybody else who opens your particular PowerMill session while you have it open, they can't edit it. That it comes in as read only. Okay, so what we want to do is we want to save PowerMill and we want to close PowerMill. Okay, and by doing so, that log file is now gone. All right, so we'll come back and we'll come back. So this folder, your section number, your name, has your PowerMill session and your digital geometry already in place. What you're going to do is you're going to right click on that and you're going to say send to compressed zipped folder. Okay. This compressed folder is what you're going to give your GAs, and that's what they are going to give to me. All right, and that's what it's going to essentially. What you're giving us is you're giving us your geometry, and you're giving us your PowerMill session. And now you're done completely. So that's all I've got. The theory is this should be relatively painless. What we want to enable is a fairly seamless exploration of the Rhino to PowerMill to Rhino to PowerMill process. Okay. Do not be afraid if you don't like what the pattern looks like. Go back into Rhino, make some tweaks, make something different, re-export it, bring it back in, and do those things again. It's relatively simple, it's relatively straightforward, and most importantly, it's quick. If I wasn't doing the tutorial, you could probably do all the programming and pattern exploration in maybe 15 to 20 minutes. Where that number kind of comes into play, though, is how many times you want to go back and forth between Rhino. Okay, so time is not really an issue. The first time you do it, it may take a while. Okay, but the second time you do it, the third time you do it, the more that you do it, the easier it becomes. If you run into problems, then come get your GA, or come get me, or come get Lauren, and we will help you through the process. It should be relatively straightforward, and it should be relatively painless, but more importantly, it should be very, very fun. So that's all I've got. Good luck, Godspeed, happy programming, and we will see you later. See ya.